Hello students, welcome to the EPG Pathshala. I am Dr. Richa Singh, working as a scientist in Dairy Chemistry Division, ICAR National Dairy Research Institute. Today we will discuss about the thin layer chromatography under the paper Biochemical Techniques. What is chromatography? Chromatography is a general term that is applied to a wide variety of separation techniques based upon the distribution or partition of sample molecule between mobile and the stationary phase. The mobile phase can be of two types, either gas or a liquid, and the stationary phase also can be of two types, either liquid or solid. So, depending upon the different combinations of stationary and mobile phase, there are two basic principles behind every chromatography. Either it can be adsorption chromatography, that is also known as the solid liquid chromatography. In this case, stationary phase is solid and mobile phase can be liquid or gas. The second principle is the partition chromatography. It is also known as the liquid chromatography. In this case, stationary phase is liquid and mobile phase can be gas or a liquid. The thin layer chromatography is come under the category of partition chromatography. As you all know that thin layer chromatography is a very old and efficient technique, but before thin layer chromatography, one technique, paper chromatography, was in fashion. But when TLC came in existence, it has widely replaced the paper chromatography because of its more robustness, more sensitivity and more reproducibility. In case of chromatography, two basic chromatography can also exist. One is the normal phase chromatography, another one is the reverse phase chromatography. In case of normal phase chromatography, if a stationary phase is polar and mobile phase is non-polar. If you reverse the polarity of phases, it means stationary phase become non-polar and mobile phase become polar, then it comes under the category of reverse phase chromatography.
Module on thin layer chromatography is covered under two different parts. This is part A of the module. In part A, I have made efforts to impart preliminary knowledge on thin layer chromatography and covered subject matter which is essential to understand part B of the module.
So, in this module, we will learn about the principle of thin layer chromatography, then how the TLC is performed, that covers the practical aspects, then advantages, disadvantages and the applications of thin layer chromatography. Thin layer chromatography is a classical case of adsorption or solid liquid chromatography or planar chromatography. In planar chromatography, the stationary phase is applied on a flat surface and movement of mobile phase is due to the capillary action. The stationary phase is normally a polar absorbent and the mobile phase is either a single solvent or mixture of solvents. Adsorption is a concentration dependent process, and in contrast to partition coefficient, liquid-liquid chromatography, adsorption coefficient is not constant. Hence, if the concentration of sample is more than the absorptive capacity of a stationary phase, the separation of components of the mixture will be poor. Thin layer chromatography is a useful tool for separating and identifying compounds from a mixture of compounds. The principle of thin layer chromatography. The thin layer chromatography is a chromatography technique which has a liquid mobile phase and a solid absorbent as a stationary phase. It is called thin layer because a solid phase of high surface area is coated as a thin layer onto a solid support. This inert support is usually a glass plate, a metal foil or plastic. Mobile phase contains a single volatile organic solvent or a mixture of solvent. The sample consisting of compound to be separated is applied as a small spot near the edge of the TLC plate, which is then dipped into the mobile phase. The mobile phase flows through the adsorbent material by capillary action, passes over the spot and continues moving the components of the mixture to different extent in the direction of flow, resulting in separation of these components. The component which is held strongly by the stationary phase will elute the last while the component which is held weakly by the stationary phase will be eluted out first. Separation of compounds occur as the stationary phase binds to the solute and mobile phase tries to dissolve it away, carrying the compound along as solvent moves in the plate. The compounds move up to the point of equilibrium between stationary and mobile phase. This equilibrium is decided by the intermolecular forces, van der Waals, electrostatic, hydrogen and hydrophobic bonding, and depends upon number 1, the polarity and size of molecules, number 2, polarity of a stationary phase, and number 3, polarity of solvent. What are the different system components of the thin layer chromatography? The first is the stationary phase. The TLC plates are chemically inert and stable, where a thin layer of about 0.25 mm thick of a stationary phase is applied on its surface. The stationary phase, consisting of uniform particle size, is applied on the plates, resulting in uniform thickness. The finally divided adsorbent, particle size ranging from 10 to 14 micro, serve as the stationary phase and is coated on the supporting material. Most commonly used solids in thin layer chromatography are silica gel and alumina. The covalent network of these adsorbents create a very polar material. The silica gel is acidic in nature and thus offer the poor separation of basic samples, whereas different forms of alumina are available like neutral alumina, basic alumina and acidic alumina. However, alumina cannot separate the large sample sizes unlike the silica gel under a given layer thickness. Alumina is also more reactive compared to the silica gel that also limits its uses. The common stationary phases of TLC, it can be divided into two categories. One is organic and another one is inorganic. In case of organic, the cellulose and Kieselguhr are the basic stationary phases, and their typical applications are identification of amino acids, carboxylic acid, alcohol, fatty acids, carbohydrates and sugar. The inorganic stationary phase can again be divided into two categories. The one is the most strongly adsorbent and another one is least strongly adsorbent. In case of most strongly adsorbent, the examples are alumina, charcoal and fluorosil. And in case of least strongly adsorbent, the example is silica. The most strongly adsorbent can be used for the identification of aflatoxin, alkaloids, vitamins, amino acids, peptides, carbohydrates, lipids and pesticides. The least strongly adsorbent, that is silica, can be used for the identification of steroids, amino acids, hydrocarbons, bile acids and vitamins. Now second component is binder. The layer of a stationary phase must be uniform, smooth, thin and durable in order to obtain the ideal separation. In addition to the coated plate should ensure consistent chromatography properties. Therefore, the use of a binder provides the stability to the layer of a stationary phase both in the dry as well as in the wet form. Binder facilitate the adsorbent sticking to the support. The common binders that are used are gypsum, plaster of Paris. The concentration of the binder is 10 to 15% by weight of gel. However, due to the high solubility of the gypsum binder in the aqueous solution, they are not recommended for the use with the mobile phase that contain water more than 20%. The silica plates with plaster of Paris binder are denoted as silica gel G, while those without binder are denoted as silica gel H. Carboxymethyl cellulose, starch, and polyvinyl alcohol can also be used as a binder. These give a stronger binding but get charred on treatment with the strong sulfuric acid solutions and heating. The preparation of TLC plate. For preparation of TLC plate, the absorbent can be silica or alumina along with binder is mixed with water to form slurry. The slurry is transferred to the spreader, hopper or applicator and applied evenly on the support in one operation. The applied slurry is allowed to set without any disturbance and dried for about 30 minutes. The dried plates are activated at 105 degrees centigrade for 30 minutes. However, commercially manufactured pre-coated TLC plates are available nowadays. Sometimes you will find a fluorescent indicator is also added in the adsorbent material, which ensures that the separated spots are visible under UV light, that is 254 nanometer. So, the silica plates with binder and the fluorescent indicator are denoted as silica gel GF. In general, the TLC is mainly used as analytical chromatography rather than a preparative chromatography. However, if you use the thicker layer, that is more than 2 mm of a stationary phase, and larger plates can be used as a preparative tool. For the recovery of sample in preparative method, the spot is cut and then the substance is extracted from the absorbent using suitable solvent. The next component of the TLC is mobile phase. The mobile phase for TLC can be a single solvent or preferably a mixture of solvent. Since separation depends upon the distribution of compound between the stationary and mobile phase, the solvent should show high selectivity in its ability to dissolve the substances being separated. The movement of different compounds depends upon their solubility in solvent system. The ability of a solvent for elution is mainly related to whether it is strongly or weakly adsorbed onto adsorbent. The commonly used adsorbent in TLC, silica and alumina are highly poor. Hence, their eluting strength increases with polarity of solvent used in mobile phase. The process of finalizing an efficient solvent system is difficult and time consuming. If a mobile phase has not been defined previously for a separation, non-polar solvent is tried initially and its separation is observed closely. If components of the mixture are not separated efficiently, a polar solvent can be introduced. In most cases, the better separation is usually achieved by the combination of polar and non-polar solvent. For a particular system, the best suited solvent system is always determined by hit and trial method. Dear students, up to now we have covered the theoretical aspect of thin layer chromatography. Now we come to the practical aspect of thin layer chromatography, means how it is performed on the bench. Now you have the prepared TLC plate, means that stationary phase is already applied to the solid support. Now you take the prepared TLC plate, with the help of a pencil you will mark the TLC plate above 1 centimeter from the bottom. Why we are using pencil? Because if you use the pen, then the mobile phase can carry the ink of the pen also and it will interfere with the identification of the spots. Second, after you have applied, now you have to apply the sample. The sample is applied with the help of a syringe. The care you have to take, the sample diameter should not be more than 1 mm, because if more the sample diameter, it can overlap the spot and also interfere in the identification of the spots. Now third step is the development of the TLC plate. For development of the TLC plate, you have to make a contact between the stationary phase and the mobile phase. So you can take the mobile phase in a jar. It can be as simple as the flat bottom beaker, or it can be specified jar for the thin layer chromatography. If you are using a high polarity mobile phase, then care should be taken that you have to pre-saturate the chamber. The chamber is pre-saturated by pouring the mobile phase in the chamber. Then you have to place a filter paper along the wall of the chamber and you have to cover the lid. Now you can keep it aside for 10-15 minutes. It will pre-saturate the chamber. So once you have pre-saturated the chamber, you can pour your plate into the chamber and you can leave it for some time. The mobile phase will start rising up through the action of capillary. The care here you have to take is the sample should be above the mobile phase, because if you have put the mobile phase above the sample, then your sample before moving will be washed away. So this care you have to take. So once you have placed your plate into the chamber, you just closely monitor it, and as it approaches the end, before approaching the end, you have to remove the plate and immediately draw the solvent front. That will help you to calculate the RF value.
You are required to refer Part B of the module on thin layer chromatography for acquiring complete knowledge.